Jai Hind everyone, I am Dr. Neha Singh, Assistant Professor of Computer Science Engineering Department from Akgec Engineering College. Today we discuss the topic regression modeling. First we know that what is a regression modeling. So regression modeling is a basically statistical modeling technique which is used to show the relationship between variables. Which means show the relationship between dependent and independent variables relations. So regression analysis matlab dependent variable means which are based on independent variable. So regression analysis is a form of predictive modeling technique which investigate the relationship between dependent, which means target variables, and independent variable, which means predictor variable. So this regression modeling is basically used for forecasting, time series analysis, and also find the causal effect relationship between the variables. So first we take the one example of the regression modeling. So predicting salary based on the year of experience. So here in this example, predicting salary is a dependent variable and year of experience based on the independent variable. And now we take the another example, predicting exam score based on the study hour. So in this example, predicting exam score based on study hour. So study hour के basis पे हम predict कर रहे हैं student का exam score. So here with the exam score is a dependent variable and study hours based on a dependent variable. So now we take another example, predicting resale price based on the vehicle age. So resale price of vehicle is dependent on the vehicle age. So this is the example of regression modeling. And we take another example for the relationship between the rash driving and the number of road accident a driver causes is the best suited through the regression, studied through the regression. So now regression modeling predicts the continuous or real values such as temperature, age, salary, price, etc. So regression analysis is important tool for modeling and analysis of data. Regression models are widely used in data analytics techniques that allow the identification, estimation of possible relationship between pattern, variables, and factors that influence that pattern. It helps to regression modeling also help to understand the relationship between dependent and independent variable. And now next topic is discussed is the benefits of regression modeling. So firstly, it indicates the significant relationship between dependent and independent variables. So it next it indicates the strength of the impact of the relationship between multiple independent variable on a dependent variable. Now next is the use of regression analysis. So regression analysis basically used for the prediction of continuous variable, which means infinite number of values. In various scenario in real world where we need some future predictions such as weather condition, sales prediction, marketing trends, etc., we need some technology. Then we can make predict more accurately. So in such cases we need regression analysis, which is a statistical method used in machine learning and data science for predicting the relationship between the variables. Now next is a type of regression technique. So type of regression technique basically classified in based on the three parameters. So number of independent variables, shape of regression line, and types of dependent variable. So in these three parameters we classify the regression analysis techniques. Now types of the regression analysis techniques basically classified in 6 parts. First is a linear regression, second is a logistic regression, third is a polynomial regression, and fourth is a support vector machine, fifth is a decision tree regression, and sixth is a random forest regression. So first we discuss about the linear regression. So in which name shows linear regression, which means linearly draw the straight line. So linear regression is the most widely known modeling techniques. In this technique, the independent variable is continuous and and the dependent variable is a continuous and the independent variable can be continuous or discrete, and the nature of regression line is linear, यानी कि linear regression. So nature of the regression line is a linear. So linear regression basically is a statistical method that used for predictive analytics. It shows the relationship between continuous variable, which means infinite number of values, shows the relationship between infinite number of values between two variables. It is used for solving regression problem in machine learning. In linear regression, show the linear relationship between the independent value x-axis and dependent variable between y-axis. Hence, it's called the linear regression. In linear regression, it is used by represented by the equation y equal to a plus b into x plus e. So here in this equation, y is a dependent variable and x is the independent variable. So in the a is the intercept and b is the slope of the line and e is the error term. Tick. So here we in this figure we show the linear relationship between dependent and independent. So we may show the relationship between height and weight. So here the relationship between height and weight is show the straight line is the linear relationship. So the straight line between two variables. Now second types regression modeling is logistic regression. So logistic regression is another supervised learning algorithm which is also used for classification and regression problems. So logistic regression algorithm works with the categorical variables such as 0, 1, yes, no, true, false, etc. It also used for the predictive analysis algorithm and which works on the concept of probability, which means true or false, yes, no, या 0, 1 की form में. So logistic regression is a simple example of email. So email spam, we classified the email is spam or not spam. So this is the example of logistic regression. One is a simple example of logistic regression. So logistic regression also uses the sigmoid function or logistic function, which is a complex cost function. So we show the logistic regression in a sigmoidal function. So we use the equation like a function of x equal to 1 upon 1 plus e power minus x. So function of x is the output between 0 and 1 and x is the input function and e is the base of natural algorithm. And here graph show the curve line. In logistic regression, not show the relationship between in a straight line. It shows a curve line structure because it uses the sigmoidal function. Now third types is polynomial regression. So polynomial regression is a type of regression modeler. The non-linear data set using the linear model. In this regression technique, the best fit line is not a straight line. So it is rather than curve that fits into the data endpoint. In this figure, show the relationship with x-axis and y-axis between. It shows the not a straight line in polynomial regression. It shows the curve line structure. Curve line draw the relationship between curve structure. So next type is support vector regression. So support vector regression is also a part of supervised learning algorithm which can be used for regression as well as a classification problem. So if we use it for regression problem, then it is termed as support vector regression. So support vector regression is a regression algorithm which works for a continuous variable, which means infinite number of values, infinite number of values between show the relationship between two variables. Now next is a decision tree. Decision tree is also a supervised learning algorithm which can be used for both classification and regression problem. So in decision tree, show the tree-like structure. In a decision tree constructed starting from the root node or parent node, which splits into left or right node, which called the child node or leaf node. This child node functions divided into their children and themselves become the parent node of those nodes. Next is the random forest regression. is the last types of the regression modeling is the random forest regression. So random forest is one of the powerful supervised learning algorithm which is capable of performing regression as well as a classification task. So random forest regression is a ensemble learning, which means ensemble learning combine the two or more algorithms or techniques to produce the average result. So random forest regression is a ensemble learning method which combines the multiple decision tree and predicts the final output based on the average of each tree output. Now we discussed next topic is our multivariant analysis. So multivariant analysis is basically a statistical technique which used for analysis. Multivariant analysis is defining as the process of involving multiple dependent variables resulting in one outcome. This explains the most of the problems in real world are multivariant. In a regression modeling, we see the one is dependent variable and another is independent. But in multivariant analysis, just like name shows, multivariant, one is a dependent variable and many forms are independent variable, two or more than independent variables. So for example, we cannot predict the weather of any year based on the season. There are multiple factors like pollution, humidity, rain, sunlight. All are the multiple factors which affect the weather. Predicting the weather on basis of year based on the session. So in this example, weather of any year based on the season, the weather of any year is the dependent which is based on the session. So here the multiple factors, pollution, humidity, sunlight and rain. So this is the independent variable. So multivariate data analysis type of statistical analysis that involves more than two dependent variables resulting in a single outcome. Now discuss about what is the objective of multivariate analysis. So basically objective of multivariate analysis is classified in 5 parts. First is a data reduction. So in multivariate data reduction helps in the reduction and simplification of the data as much as possible without losing any important details, which means if we have a large amount of data, much amount of data, so we simplify and reduce this size without affecting any important details. So next objective of sorting and grouping. In multivariance analysis help the multiple variables, that variables are grouped sorted on their unique features. So now third is the investigation for dependence of variables. So the variable in multivariate data analysis could be dependent or independent. So it is important to verify the collected data and analysis of the state of variables. Now next objective, prediction relationship between variables. So in this multivariate analysis, it is important to understand the relationship between all the variables and predict the behavior of the variable based on the observation. Now last objective of multivariate analysis is a hypothesis construction and testing. It is a tested to create a statistical hypothesis based on the parameter of multivariate data. This testing is carried out to determine whether or not assumptions are true. Now next topic is advantage. What is advantage of multivariate analysis? So multivariate analysis, the conclusion are more realistic and nearer to the real life situations. So first advantage of this output is more realistic attached to the real life situations, nearer to the real life situations. So the main advantage of multivariate analysis that since it considers more than one factor of independent variable that influence the variability of dependent, the conclusion is drawn is more accurate because possibility are more. So next topic, disadvantages of multivariate analysis. So the main disadvantage of multivariate analysis include it require rather complex computations to arrive the satisfactory conclusions. Many observations for many variables need to be collected and tabulated. It is rather time time consuming process. So multivariate data analytics techniques. So basically multivariate data techniques classified in two parts, dependence technique and interdependent technique. But dependence methods or techniques. So dependence methods are used when one or more of the some variables are dependent on others. We taking the example like predicting salary based on year of experience. So predicting salary, here predicting salary is a dependent variable and year of experience is independent variable. So in this example सैलरी के बेसिस पे हम क्या कर रहे हैं, ईयर ऑफ एक्सपीरियंस के बेसिस पे हम सैलरी को प्रेडिक्ट कर रहे हैं. तो यहाँ पे सैलरी जो है आपकी प्रिडिक्टिंग सैलरी, तो ये डिपेंडेंट है, ईयर ऑफ एक्सपीरियंस इंडिपेंडेंट. सो in machine learning, dependence technique are used to build predictive model that analysis input data into the model, specifying which variable are independent and which are dependent. Now next type of multivariate and interdependence methods. So interdependence methods are used to understand the structural makeup, underlying patterns within a data set. In this case, no variables are dependent on others. So you are not looking for causal relationship. Rather, independence method seeks to give meaning to a set of variables or to the group them together in a meaningful way. So we discuss about the multivariate analysis technique is two techniques, dependence and independence. Now next topic is a common multivariate analysis. Some common multivariate analysis technique use a multivariate analysis techniques. So in common multivariate technique is classified in 5 parts. First is a multiple linear regression, multiple logistic regression, multivariate analysis of variance, factor analysis and cluster analysis. Now first we discuss about the multiple linear regression. Before we discuss about the linear regression, so in this linear regression, one is a dependent variable and other is a independent variable. But is in here multiple linear regression, yani multiple linear regression dependence method which look at the relationship between one dependent variable and two or more independent variable. Take a multiple regression model will tell you the extent to which is independent variable and has a linear relationship between a dependent variable. This is helpful you to understand which factors are likely influence the certain outcome of following you to estimate the further outcomes. So multiple linear regression, so best example of crop yield. So crop yield is a dependent variable. So in this basis, crop yield, humidity, pollution, sunlight, rain is the more are the independent variables. This is a two or more independent variable. So now next types multiple logistic regression. In the multiple logistic regression analysis used to calculate the probability of binary event occurring like 0 and yes, no, true or false. So it is used for basically classification. So multiple logistic regression is a best example of email. This email is spam or not spam. Easily classified. Email is important or not important. Email going to So next is a multivariate analysis of variance. So multi-analysis of variance, it used to measure the effect of the multiple independent variable and two or more dependent variable. With multivariate analysis of variance, it is important to note that the independent variables are categorical while dependent variables are the metric in the nature. So the best example of multivariate analysis of variance is the employment status. So employment status could be characterized into certain such as employed full time, employed part time, unemployed. So many factors are independent variables. A metric variable is measure the quantitatively and task takes on a numerical value. Next is the factor analysis. So factor analysis is independence technique which seeks to reduce the number of variables in data set. So if you have too many variables, it can be difficult to find out in your data. At the same time, model created using data set with too many variables are susceptible to overfitting. So overfitting is a modeling error that occurs when model is fit too closely and is specified to a certain data set, making it generalizable to further data sets. These variables may then can consider into a single variable data. Data analysis often carry out factor analysis to prepare the data subsequent analysis. So cluster analysis, the last common multivariance analysis is cluster analysis. So in cluster we divide the cluster in a homogeneous and heterogeneous peer group, यानी similar type and different types of data को एक एक group में हम organize करते हैं. So in cluster analysis, another independence technique, cluster analysis is used to group similar item within a data set into cluster. So in a cluster analysis, this is a measure in terms of intra-cluster and inter-cluster. So in intra-cluster, distance looks at the distance between data point within the one cluster. This should be, intra-cluster should be small. So inter-cluster distance looks at the distance between data points in difficult cluster. This should ideally be large. Now next is a support vector machine. Support vector machine is one of the most popular supervised machine learning algorithm, which is used for basically classification as well as regression problem. So primarily it is used for classification problem in machine learning. So in support vector machine, the goal of support vector machine algorithm is to create the best line or decision boundary that can segregate n-dimensional spaces into classes so that we can easily put the new data point in the correct category. In the further this best decision boundary is called the hyperplane. So in support vector machine, given the two classes, we separate the two classes with the help of decision boundary or hyperplane. So in support vector machine, choose the extreme points or vector that help in creating the hyperplane. These extreme cases are called as support vector, and hence algorithm is termed as support vector machine. So here we look at the diagram. So in this diagram, this is shows as the x-axis and this is the y-axis. So in this diagram, given the two classes, one is a circle and one is a square. So these two classes are categorized with the help of hyperplane. So one class is a green line and one is a blue line. So in two separate two classes, we use the hyperplane, and these two lines are a decision boundary, shows the decision boundary. In the SVM, we use and these two classes is known as a support vector. So which support vector are nearer to the decision boundary? And in decision boundary, we calculate the maximum margin. What is the maximum margin of two support vectors? Here the example of support vector machine. I have a cat with some features similar to the dog. So how we classify it is a dog or it is a cat? So first we train the model. So then model is train, then predict it is a cat or dog. So in prediction class some unique feature classify, so it is a dog or it is cat. So in a prediction find the new data is arise, so it is a find as it is a cat. So output is arrives as the output is a cat. Now the hyperplane and support vector in SVM algorithm. So hyperplane basically separate the two classes. In support vector machine used for separate two classes. it used for hyperplane. So there can be multiple line decision boundaries to segregate the classes in n-dimensional space. We need to find out the best decision boundary that helps to classify the data point. This best boundary is known as the hyperplane of SVM. So the dimension of hyperplane depend on the features present in the data set, which means in the in there are two features, then hyperplane will be a straight line, and if there are three features, then hyperplane will be a two-dimensional plane. So next is the type of SVM. So SVM is basically classified in two parts: linear SVM and non-linear SVM. In linear SVM, it is used for linearly separable data, which means if data set can be classified in two classes by using single straight line, then such data is termed as linearly separable data, and classifier used called as linear SVM classifier, which means linear support vector machine classifier. So now next part is a non-linear SVM. So non-linear SVM support vector machine is used for non-linearly separable data, which means if data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used as a non-linear support vector machine classifier. That's all. Thank you.